Hello, good day friends. In today's question, once again, we are asked to calculate the blue area, that is the area of this triangle ABP. We have the length of this side to be 15 millimeters, while this segment BP has its length to be 9 millimeters. This angle BAP has its size to be A, and similarly, this angle CAD also has its size to be A. That tells us that the two angles are congruent. And from here, they said line CD is a tangent to the semicircle. So how can we solve this? It is actually very simple. Starting from here, they said line CD is a tangent to the semicircle. That is, at this very point here, this side CD is a tangent to this semicircle. Now, since this is a semicircle, we know this is its diameter. The diameter is actually 2 radii. From the circle theory, there is a rule that the tangent of a circle is perpendicular to its radius through point of contact. That is, this side CD is perpendicular to this side, so this angle is a right angle. Now look at this triangle ACD. Because of this right angle here, it is a right angle triangle. So we can use a SOHCAHTOA. Taking this angle as theta, this is the opposite, this is the adjacent, and this is the hypotenuse. Let's assume the length of this adjacent side to be y. From here now, TOA means tan theta equal to opposite over adjacent. Theta is A, opposite is 15, and adjacent is y. So tan A equal to 15 over y. Now from trigonometry, there is an identity that tan x equal to sine x over cos x. We let x equal to A, substitute here. Now tan A equal to sine A over cos A. That is, this tan A is sine A over cos A. So sine A over cos A equal to 15 over y. Okay, now come back here. Look at this angle ABD. It is subtended by this diameter to the circumference. From the circle theory, any angle subtended by a diameter of the circle or semicircle to the circumference is an angle of a semicircle, which is a right angle. So this angle is a right angle. This makes triangle ABD a right angle triangle. So we can also use a SOHCAHTOA. Taking this angle as theta, theta equal to A plus A, which is 2A. This side is the opposite. Since this part is 9 millimeters, we label this part Z. So opposite equal to 9 plus Z. And this is the hypotenuse. Therefore, hypotenuse equal to y. From here, sine theta equal to opposite over hypotenuse. Substitute these values here. So sine 2a equal to 9 plus z over y. Now from trigonometry, once again, there is the double angled identity that sine 2x equal to 2 sine x cos x. Let x equal to a. Put it here. Now sine 2a equal to 2 sine a cos a. Come here, replace this sine 2a with 2 sine a cos a. So 2 sine a cos a equal to 9 plus z over y. We divide this equation, sine a over cos a equal to 15 over y, by this equation. So sine a over cos a all over 2 sine a cos a equal to 15 over y over a plus z over y. This y cancels this y, and this sine a also cancels this sine a. 1 over cos a over this 2 cos a is 1 over cos a divided by 2 cos a. We can change this division sign by taking the reciprocal of this 2 cos a. So it is now 1 over cos a times 1 over 2 cos a. 1 over cos a times 1 over 2 cos a is 1 over 2 cos squared a. So 1 over 2 cos squared A equal to 15 over 9 plus Z. Cross multiply. Now 2 cos squared A times 15 equal to 1 times 9 plus Z. 2 cos squared A times 15 is 30 cos squared A. And 1 times 9 plus Z is 9 plus Z. So 30 cos squared A equal to 9 plus Z. Divide both sides by 30. Here 30 cancels 30. So cos squared A equal to 9 plus Z over 30. Now what is Z? We don't know. But if you come here with this triangle ACD, we have the size of this angle to be A, and this angle is 90 degrees. Based on the rule that the summation of angles in a triangle is 180 degrees, this angle must be 180 degrees minus 90 degrees minus A. 180 degrees minus 90 degrees is 90 degrees. So the angle is 90 degrees minus A. Now from this triangle also, since this is 90 degrees and this is A, this must be 180 degrees minus 90 degrees minus A, which is 90 minus A. If you now look at this angle and this angle, they both are formed by two straight lines intersecting at this point. That is, they are vertically equal angles. So since this angle is 90 degrees minus A, this must also be 90 degrees minus A. Let's put our focus on this triangle CDP. We can see this angle and this angle are congruent. That proves that triangle CDP is an isosceles triangle. We know the side facing the congruent angles are also equal. That is this side and this. So since A is 15 millimeters and this is Z, that means Z equal to 15 millimeters. We come here, substitute the value of Z. So cos squared A equal to 9 plus 15 over 30. 9 plus 15 is 24. 24 is same as 8 times 3. And 30 is 10 times 3. This 3 cancels this 3. 8 is 4 times 2. And 10 is 5 times 2. This 2 cancels this 2. So cos squared A equal to 4 over 5. Take the square root of both sides. Here square root of cos squared A is cos A, while here square root of 4 over 5 is square root of 4 over square root of 5. Square root of 4 is 2, so cos A equal to 2 over root 5. 2 over root 5 multiplied by 1 is still 2 over root 5. And n over n is also 1. Replace this one with n over n. 2 over root 5 times n over n is 2n over root 5n. So cos A equal to 2n over root 5n. Come to this triangle ABP. Use the SOHCAHTOA. Taking this angle as theta, there is the adjacent and there is the hypotenuse. From here, cos theta equal to adjacent over hypotenuse. Theta is A, so cos A equal to adjacent over hypotenuse. Recall here cos A equal to 2n over root 5n. Replace this cos A with 2n over root 5n. So 2n over root 5n equal to adjacent over hypotenuse. And from this, we obtain adjacent equal to 2n and hypotenuse equal to root 5 over n. That is, this adjacent is 2n, while this hypotenuse is root 5n. Now still on triangle ABP, we can use the Pythagorean theorem. The Pythagorean theorem states that the square of the length of the hypotenuse of a right angle triangle is equal to the sum of the squares of the length of the two other sides. The hypotenuse is the side facing the right angle. So using the Pythagorean theorem and the triangle, root 5n all squared equal to 2n all squared plus 9 squared. 9 squared is 81. 2n all squared is 4n squared. And here root 5n all squared is 5n squared. So 5n squared equal to 4n squared plus 81. Take 4n squared to the left. So 5n squared minus 4n squared equal to 81. 5n squared minus 4n squared is 1n squared. So n squared equal to 81. Take the square root of both sides. Here square root of n squared is n. while here square root of 81 is 9. So n equal to 9 millimeters. Substitute it here. Now 2 times 9 millimeters is 18 millimeters. Now we know the formula for calculating the area of a triangle is 1/2 base times height. From this triangle, we will take this as the base. This must be the height. So b equal to 9 millimeters and height equal to 18 millimeters. Substitute here now. Area of triangle ABP equal to 1/2 times 9 times 18. 1/2 times 9 times 18 is 81. So area of triangle ABP equal to 81 millimeters squared. That is, the area of this triangle, which is the blue area we are asked to calculate, is 81 millimeters squared. Thank you for watching. Please subscribe, like, share and comment, and also turn on notifications. Thank you.